All right, let's dive right in. Today, we're talking about the incredible science that's happening inside your mouth. Not just your teeth, but the stuff dentists use to fix them. Fillings, crowns, implants. These materials have to survive in one of the toughest, most challenging environments you can possibly imagine. I mean, seriously, have you ever stopped to think about it? You're drinking piping hot coffee, crunching on snacks, and your mouth is basically a 24/7 chemical bath. And yet, that little filling is supposed to just hang in there for years without disappearing. How is that even possible? Well, that's exactly what we're going to figure out. So, first things first, we need to change how we think about the mouth. It is not some calm, peaceful place. No way. For any man-made material we put in there, it is a full-on, non-stop battlefield of chemical and physical warfare. Just look at this chemical roller coaster. 1 minute, you take a sip of soda, and bam, the pH plummets down to a corrosive 4. The next minute, you brush your teeth, and whoosh, it can shoot all the way up to an alkaline 8.5 or even higher. This constant chemical whiplash is enemy number one for any material just trying to hold on. Okay, so with all that chemical chaos swirling around, the first major threat is pretty obvious, right? The material could simply dissolve away into nothing. Let's break down how that actually happens. The technical name for this is erosion. But honestly, the best way to think about it is to picture a sandcastle at the beach. First, the acidic waves from your food and drinks soak the surface, weakening all the bonds and turning it kind of soft and mushy. That's the chemical part of the attack. And then comes part two. And you know what? It doesn't even take much force. Simple things like chewing, your tongue moving around, or even just swishing liquid are enough to wash that weakened, mushy layer right off. And what does that do? It exposes a brand new, fresh surface for the acids to attack all over again. It's just a brutal, relentless cycle. Weaken, remove, repeat.
But wait, it gets even more complicated. It's not just about material being lost from the surface. Sometimes, tiny little components can leak out from the inside of a material. This process is called leaching, and, it can be a double-edged sword.
And this is a perfect example of how leaching can be both a villain and a hero. Think of it like a tea bag. Harmful leaching is like a soft denture liner losing all the good stuff, the plasticizer that keeps it soft. It leaks out and the liner becomes hard and pretty much useless. But helpful leaching? That's like a special tea bag that slowly releases fluoride to help your teeth fight off cavities. See? Same process, totally different results. So that brings up a really smart question. If leaching can make a material fall apart, how in the world do these helpful materials release fluoride without just crumbling away? Well, the secret is how it happens. If it's just washout where bits of the material just dissolve and disappear, yeah, the whole thing falls apart. But if it's something called ion exchange, this is really cool. A fluoride ion pops out, but another ion from your saliva, like a hydroxyl ion, pops right back in to take its place. The structure stays solid. It's a genius solution. Okay, for our next section, we're talking about the big boss, the ultimate enemy for any metal or alloy in your mouth, corrosion. And let me tell you, this is not simple dissolving. This is an all-out electrical war. To get this, you gotta look at what's basically a league table for metals. It ranks them based on how eager they are to react. The rule is super simple. Metals with a big negative value, like zinc and chromium, are itching for a fight. They want to give away their electrons. But the ones with positive values, like gold and platinum, they're the noble, stable ones. They prefer to keep to themselves. So, what happens when you put two different metals from this league table right next to each other in your mouth? You got it. You create a tiny little battery. Your saliva acts as the perfect conductor, the electrolyte. The more reactive metal, in this case zinc, becomes what we call the anode. It gives up its electrons and dissolves, literally corroding away. The less reactive metal, copper, becomes the cathode, where all those electrons end up. All right, pop quiz time. Let's see if you've got this. In our tiny little mouth battery, which metal is the anode, the one that actually corrodes away? Is it the zinc or the copper? If you said zinc, you nailed it. The anode is always the more reactive metal, the one that's just desperate to give away its electrons. And if you thought that was wild, get this. This whole battery thing doesn't just happen between two different fillings. It can happen inside a single filling. If an alloy isn't mixed perfectly, you get these tiny little zones with different compositions, and they start acting like mini anodes and cathodes, fighting each other. The filling basically starts a civil war with itself and corrodes from the inside out. It's crazy, right? So that brings us to a fascinating puzzle, a real head-scratcher. If you look back at that reactivity chart, chromium is way over on the reactive side. It wants to corrode. So why on earth do we add it to alloys to prevent corrosion? How does that even make sense? The answer is a superpower with a really cool name: passivation. Yes, chromium is super reactive. In fact, it's so reactive that the instant it hits the air, it forms an ultra-thin, incredibly tough, and totally invisible layer of chromic oxide. This layer acts like a perfect force field, sealing the metal underneath and protecting it from any more attacks. How cool is that? So, you see, the big takeaway here is that by understanding all these enemies, erosion, leaching, and corrosion, scientists and dentists can be way smarter about how they choose and design materials that can actually survive on that battlefield. And there are other sneaky enemies to watch out for. Stress, like from flexing a metal appliance, can actually speed up corrosion, and having a rough surface is a huge no-no because tiny little pits can trap debris, creating low oxygen zones that become perfect little corrosion hotspots. This is exactly why your dentist spends so much time polishing your fillings to make them perfectly smooth. And why does all this matter? Well, because when corrosion wins, the consequences are serious. You can feel pain from those tiny electrical currents, get a metallic taste in your mouth, the restoration can look terrible, and worst of all, it can release metallic ions like mercury and nickel into your body. So yeah, it's a big deal. So to wrap it all up, the recipe for a hero material that can win the battle in your mouth is pretty clear. It needs to be resistant to dissolving and erosion. If it's a metal, it has to be highly resistant to corrosion or have that passivation superpower. It must have a perfectly uniform internal structure. And finally, it needs a super smooth, polished surface. And that leaves us with one final thought to mull over. Our world is changing. We have new energy drinks, new foods, new habits. What new chemical attacks are we creating in our mouths? And what new superpowers will the dental materials of the future need to invent to survive? It's definitely something to chew on. Thanks for joining us.